everyone and welcome back to my channel. In previous video, we have seen first two topics of foundation models, which are deep learning, generative AI and foundation models, and how to choose those models depending upon the use case. In this video, we are going to see the Google strategies for foundation models and its limitations. After that, we will see the quizzes. At the end of this video, we will also discuss what kind of questions you might get from these topics. So see this video till the end and keep learning. So with this, we will start with the Google strategies for foundation models. We just talk about the tech behind the generative AI and how it uses data and foundation models. So it's changing the way we work, whether it's marketing, writing, or even coding. It's a very powerful tool, but sometimes it gives answers that sound right but are completely wrong. This is called a hallucinations. To avoid that, we need something called grounding. Grounding means connecting the AI to real trusted data. So it doesn't just guesses. It keeps the AI focus on the facts, not the fictions. In a business or an enterprise, setting grounding means feeding the AI with your own data like internal documents, reports, customer info, or code. This way, the AI understands your language, your goals, and your context. It stops the AI from giving generic responses. Instead, it gives you accurate, relevant, and useful answers tailored to your needs. Think of a grounding as a reality check. It's a safety net that helps AI to stay aligned with your organization. In this session, I will talk about fine-tuning and RAG, which is Retrieval-Augmented Generation. Grounding and RAG are two key methods to ground generative AI. Let's explore how you can use these tools to build smarter, more reliable AI systems. Whatever we just discussed is mentioned in this video in the form of podcast. Let's see foundation models limitations. So recognizing these limitations is essential for the responsible and effective utilization of these powerful tools. We'll go through these limitations one by one. First one is a data dependency. The performance of foundation model is heavily data dependent. They require large datasets, and any biases or incompleteness in the data can turn out into their outputs as well. So it's like a student who writes an essay on a book they haven't read. If a data or a questions are inaccurate or biased, the AI's performance will suffer. It's very important to feed your AI model with appropriate data. Then the second one is knowledge cutoff. Models with the older knowledge cutoffs may not know about the recent events or the discoveries. This can lead to the incorrect or outdated answers, since AI models don't automatically update with the latest happening around the world. For an example, for an AI tool, the last training date was in 2022. It wouldn't be able to provide the information about the events or the information happened after 2022. The third one is the biases. An LLM learns from the large amount of data, which means they contain the biases. You can think of a bias as a unbalanced data in LLMs. Due to their statistical learning nature, they can sometimes amplify existing biases present in the data. Even subtle biases in the training data can be magnified in the modern output. It's very important that we should feed the AI system with a unbiased data. Then the fourth one is fairness. Even if the data is balanced, it's still hard to define what fair means in the output of a any language model. Fairness can mean different things to different people. There are some tests to check the fairness in AI, but they have a limits. They usually look at only a few types of biases and miss others. So this test don't show the full picture, and it's still a big challenge to make AI truly fair for everyone. Then the fifth one is hallucinations. Foundation models can sometimes experience hallucinations, which means they produce output that are not accurate or based on a real information. Because foundation models can't verify information against external sources, they may generate factually incorrect or no essential responses. This causes significant concern in accuracy in critical applications. These responses might sound convincing, but they are completely wrong. One is edge cases. There are rare and atypical scenarios which can expose a model's weakness, leading to errors, misinterpretations, and unexpected results. So these are the limitations of foundation. Let's see what are the techniques to overcome these limitations. First one is a grounding. As we see, verifying the data with an actual uh, source is a grounding. Let's see what's mentioned here. So generative AI models are amazing at creating content, but sometimes they hallucinate. Grounding is a process of connecting the AI's output to verified sources of information, like giving AI a reality check by providing the model with access to specific data. So grounding is also essential for building trustworthy and the reliable applications. So how can you do that? You can do this by connecting your models to the verifiable data. You ensure the accuracy and you build the confidence in your AI system. So it offers key benefits including reducing hallucinations, which prevents the AI from generating false or the fictional information. Grounding also anchors responses, ensuring AI's answers are rooted in your provided data. It builds trust by enhancing trustworthiness of the AI output by providing confidence sources and allows you to verify the information. So this is what a grounding is about. Now let's see what is retrieval-augmented generation, termed as a RAG. So there are many different options on how you can ground in data. For example, you can ground in enterprise data or you can ground using Google search. So one common grounding method to do this is a retrieval augmented generation or RAG. RAG is a grounding method that uses search to find the relevant information from the knowledge base and provide that information to LLM, giving a necessary context. The first step in RAG is retrieval. When you ask an AI a question, RAG uses a search engine to find relevant information. This search engine uses an index that understands the semantic meaning of text, not just the keywords. So this means it finds information based on meaning, ensuring higher relevance. And then retrieved information is then added to the prompt given to the AI. This is a augmented phase. Then AI uses augmented prompt along with the existing knowledge to generate the response. This is referred as a generation phase. There are three phases. First one is a retrieval of the information. Second one is a augmentation, and third one is a generation process. This technique is very important for getting the accurate result from the models. The third one is a prompt engineering. So prompting offers the most rapid and straightforward approach to supplying supplementary background information to models. Meaning prompting is the fastest and the easiest way to give an extra information to AI models. You can do this by writing a clear instructions to get the kind of answers you want. But it has a limit. It can't give answers about things it hasn't already learned. Then the Then the next one is fine tuning. When prompt engineering doesn't deliver a desired outcomes, fine tuning can enhance your model's performance. So pre-trained models are powerful, but they are designed for a general purpose. So fine tune is a method by which we can train the model with our desired data. So pre-trained models are powerful, but they are designed for a general purpose. This process is particularly useful for specific tasks or when you need an enforce specific output format, especially if you have examples of a desired output. To, so this tuning involves further training a pre-trained or a foundation model or a new dataset specific to your task. This process adjusts the model's parameter, making it more specialized to your needs. Here, Google Cloud Vertex AI provides tooling to facilitate tuning. Here are some examples of how tuning can be used. So it can be used as a fine-tuning a language model to generate a creative content in a specific style. Then fine-tuning a code generation model to generate a code in a particular programming language. Fine-tuning a translation model to translate between specific language or domains. These are the four techniques by which we can mitigate the limitations of foundation models. The next topic is human in the loop, HILT. Beyond these techniques, we must remember the valuable role of human in the loop. Machine learning models are powerful, but they sometimes need a human touch. For a task requiring judgment, context, or handling of incomplete data, human expertise is essential. Human in the loop systems integrate human input and feedback directly into the ML processes. So these collaborations makes model more adaptable, especially in the areas like content moderation, sensitive applications, high-risk decision making, pre-generation review, and post-generation review. Let's see all of those one by one. The content moderation. Human Human in the loop ensures accurate and contextually appropriate moderation of user generated content, filtering out harmful or inappropriate material that algorithms alone might miss. Then the sensitive application. In the field like healthcare or finances, human in the loop provides the oversight of a critical decision making, ensuring accuracy and mitigating the risk associated with automated system. Then high risk decision making, same, human in the loop is more important there. When ML models inform decisions with significant consequences such as medical diagnosis or a criminal justice assessment, human in the loop acts as a safeguard, providing a layer of human review and accountability. Then pre-generation review. Before deploying ML generated content or decisions, human expertise can review and validate the outputs, catching potential errors or biases before they impact users. And then post-generation review. After ML outputs are deployed, continuous human review and feedback help identify areas for improvement, enabling models to adapt to evolving context and the user needs. AI systems are trustworthy and most of the time gives an accurate output, but to verify this output, human in the loop is most crucial and important. Then let's review with quizzes. So it's about prompting, fine tuning and RAG techniques. There are some cards and we have to add those cards in the correct boxes. There are prompt engineering, fine tuning and retrieval-augmented generation, which is RAG. The first card is adapting the model with a task. So we have seen if an AI model is designed or developed to do some specific task, we have to do the fine tuning of and we have to teach our model with a specific learning or the specific data. So it will go under the fine tuning. crafting precise instructions for desired output. So giving a accurate or the precise instructions to get the desired output. And the third one is augmenting the model with external knowledge. So yes, it's a retrieval-augmented generation. Augmented, both the keywords are there, and what is RAG? We are augmenting this model with the external sources or the external information to our model. So this is a RAG. Yeah, that's correct. Now let's see the next question. Which of the following is the best describe the purpose of grounding in a generative AI? So as we discussed about the grounding, it's having the accurate or the reliable source of information. So let's see which of the option is correct. Option 1 is to reduce the complexity of AI model and make them easier to train. Option B is enhance the accuracy and reliability of AI generated content by connecting it to the variable sources. Option C is to encourage the AI to generate more creative and imaginative output. And option D is to improve the speed and the efficiency of AI interface. We just talk about grounding is all about verifying the resources. So option B is a correct answer. Yes, that's correct. So from this model, what are the key takeaways? Foundation models have a limitations, including data dependency, knowledge cutoffs, biases, potential for hallucinations, and issues with fairness and edge cases. But the technical grounding, prompt engineering, fine-tuning, and human-in-the-loop systems can address these challenges and improve the accuracy, reliability, and fairness of foundation models. So this chart is about the detailed summary. So let's see one by one. So it's a summary of RAG, fine tuning and grounding. So what is RAG? The definition of RAG is augmented LLM by retrieving relevant information from external knowledge bases and adding it to the prompt. What's fine tuning? It's further trains a pre-trained model into the new dataset to adapt it to specific task. And what is grounding? It's connect an AI model's output to verifiable sources of information. So what is the process of RAG? Retrieve relevant information, then add it to the prompt and generate a response. And what is a data source of RAG is? It's a always external knowledge bases like databases, documents or internet. And then what is a relationship of grounding with a RAG? It's a specific technique for achieving grounding. Then what is a process of fine tuning? For fine tuning, we have to select a pre-trained model, then gather the data, then train the model and evaluate and refine. What are the data sources for fine tuning? So there are task or a domain specific data sets. And what is a relationship to the grounding? It improves model's ability to be grounded in a specific domain. So let's remember whenever it is for specialized data or the specialized use case, fine tuning is a answer. Then grounding. So what is the process of grounding? It provides access to a data source, use RAG or fine tuning to connect the output. Then what is a data source for grounding? Mostly external knowledge bases or a specific data sets. And then what is a relationship to the grounding? Grounding is achieved by the technique called RAG and fine tuning. So you have to just remember this chart. So remember this concept. You just remember the data sources. What is the data source of RAG is a external knowledge basis, and it learns from the latest data, and the fine tuning is for the task specific domain data sets. That's it for this module. You will get the questions on fine tuning, then the prompt engineering, grounding, RAG, and then hallucinations. So 5 to 6 questions you can expect from this foundation models. These questions are not very straightforward. It won't be like what is RAG or what is fine tuning or what is grounding, but they will give you a scenario, and based on a scenario you have to analyze this scenario, and then you have to come up with a technique, which technique you will be using to improve your output. So this is kind of a questions you will be getting from this module. So let's see the quizzes. The first question is, which technique can be used to overcome the limitations of foundation model? Option 1 is grounding, prompt engineering, fine tuning, and human in the loop. Yes, we have seen these are the techniques which are used in overcoming the limitations of foundation model. But let's see what are the next options. Advanced algorithm and data structure, preventing hallucinations by restricting the AI model's access to external knowledge sources, increased processing power and faster hardware. The first option is correct. Prompt engineering, fine tuning, and human in the loop. Question 2 is, what is fine tuning and customization an important factor for choosing a model? It ensures the model is always available. It come into the reliability. So this is not a fine tuning. It increases the model's context window. Again, this is not the correct answer. It allows the model to be adaptable for a specific task or domain, and it reduces the cost of using the model. So cost is not an option. So when we are saying fine tuning, it's always for a specific task or a domain. Question 3 is, what is the primary role of in the loop in machine learning? Option 1 is to automate all decision making process. Option 2 is eliminate the need of data collection and model training. Option 3 is to replace AI algorithm entirely, and option 4 is to integrate human expertise into the ML process, especially for tasks requiring judgment or context. So we have seen human in the loop is important for review, judgments, and the context. So option 4 is a correct answer. Which type of model would be more suitable for generating photorealistic images from a textual descriptions? So we discussed this image generation is coming under the diffusion model. So let's see if we have a diffusion model in the options. Option 1 is large language model. Option 2 is classification. Option 3 is diffusion. And option 4 is multimodal. Yes, diffusion model is a correct answer. What is the primary purpose of grounding in generative AI? So when we say the grounding, we have to check the source of the information. So we have to verify the source of the information. So let's see what seems to be the correct answer. Option 1 is to reduce the cost of deploying AI application. It's not an answer. Option B is to improve AI's ability to generate creative content. So this is again not a primary focus. Option C is to connect the AI output to verifiable sources of information. And option D is increase the speed and efficiency of AI model training. So whenever is a grounding, it's just a verifiable source of information. So option C seems to be the correct answer. And the sixth question is, which type of foundation model is specifically designed to understand and generate human language? So we discussed which model is designed for that is LLM. Let's see if it's in the option. Option 1 is a multimodal language. Option 2 is a diffusion model. Option C is a predictive and the D is a large language model. Multimodal model is a model which takes multiple modalities as an input. Diffusion models create images. Predictive model predicts the trend depending upon the historical data, and large language model help us to generate a human language. Let's submit. Yes, all the answers are correct. So with this, we are at the end of the video. So with this, we have completed the foundation models. In that, we have discussed about the deep learning, generative AI, foundation models, how to choose the model, and the limitations of the model. And we saw the quizzes as well. Expect 5 to 6 questions from the topics discussed in this chapter. So if you want any topic to be discussed in next videos, please let me know in the comments. Till then, stay tuned and happy learning. Goodbye.